sure they did, because I wasn't as good of a teacher back then as I am now, and I'm still improving. Still trying to figure out how to do this thing. This is my 10th year teaching, so arguably that was 10 years ago.
Wow. Wait,
Max?
Did you have soup for lunch?
I had a stew-like amalgamation. It had potatoes and meat and beans and corn. So if you put some liquid in it, it could be soup, but there was no liquid. It was just the stuff. It was what? It was like, I mean, cereal is soup if you want to like.
Meat, vegetables, liquid.
I mean, I just had no extra liquid. It was a very, very thick soup. All right, so now that my video has started in the weirdest way possible, by us talking about what is soup or not, let's check 10.1.3. Nolan.
I have a joke for you.
Is it school appropriate?
Yes.
Then go ahead.
What does a lawyer name their daughter?
Oh no.
Sue.
I have a slightly morbid joke. I don't know.
Sorry, we can't go down this road. I should have even put the lid on Nolan's, but unless we have excess time for jokes, we don't have a lot of time for jokes. So here in a couple days, maybe. The first one they tried to tell, I asked, is it school appropriate? And they said no. And I said, all right, well, we're not doing that then. So.
School appropriate?
Yes.
All right.
What does a lawyer name their daughter? Sue.
You have to give him time to act.
All right, 10.1.3.
Wait, where's
Sir?
10.7?
Where is what?
Like for the 41, where's 10.6? That's what I was listening.
Yeah, you have to look back in the ebook.
We did it in class.
We did?
So you would have had to have looked back in your ebook or used homework help to get to that image. If you are just now realizing, wait, where's 10.37? You are throwing yourself under the bus of you didn't try your homework yet. So all things that you might be missing can be found in the ebook, homework help, or plenty of other locations. But ebook for sure would get you that image of that cone. It might have been on the 10.1.2. Nope. So yeah, I did that on purpose to make you go back and look at it because I didn't have space on this. You're going to have to sharpen that. So go ahead. On 45, I would caution you, if you use the graph space I provided you, you might want to read through the steps first before you try to graph it. So 45, you're going to end up a little higher on the y value than just 5. As you can see, if you look at the answers, you end up at a y value of 6. So you, if you say more, I don't know what you mean. Oh, sure, if you extended the graph, yeah. I mean, you can also always just do it on your own graph paper. I only give you those things so you don't have to necessarily go get another piece of paper. But the point behind what CPM's thought is you would be doing it on graph paper, and you wouldn't just have like 5x5 or 10x10. Like, you'd have a whole piece of paper. You know what I mean? So yeah, you can always extend it because there's infinite space that we can use and keep counting and giving value to.
Because you could do
I have an issue with their answer for 10.46.
Do you have an issue with the picture or the table or what?
The picture and also the.
What is your issue?
My issue is that those, like, I don't think it's correct. Because when you square root something, there's that and there's also the negative answer. 5 times 5 is 25, so it's negative 5 times negative 5.
So, I agree with you. However, here's a problem that I will own. It is my fault that you guys know that square roots have a positive and a negative value. For CPM right now, they assume, I know, assuming is really dangerous. Assuming is a bad thing. They assume you only know positive square root values. So that's why you're right. But here's why the graph we get ends up looking like that. If we graph both sides of it, then it is not a function. And by both sides, it'd really be a top and a bottom of the graph. So if you go like in depth and you do the entire square rootedness, like we'll use an easier one. What's the square root of 4? Positive or negative 2. However, if I make my graph look like that, it's going to also have this part of the graph, and then it's going to fail the vertical line test, and it all falls apart.
Yeah, that's
So, if your answers do not agree with this because you did positive and negatives, that's fine. But CPM right now thinks I haven't taught you about negative square roots.
why would you like if we learned about square roots, why would
Because when we're talking about a physical square with an area of 9, what is its root? Negative 3 doesn't make sense. We're talking about square roots that make sense in the tangible physical world. Then we get into more abstract math, where we say, well, negative 3 would also work that when it's squared becomes 9, but it wouldn't work as a side length because that's just silly.
yeah, like in the physical world it doesn't work, but in the
You guys aren't that abstract yet, but I go ahead and I teach it to you guys because I respect you as brilliant young learners that might as well be taught the whole truth and nothing but the truth. Except for when I lie to you guys. Max.
Then why does my calculator only do the top part?
Because otherwise it's not a function and your calculator is trying to force it to be a function.
Oh.
Your calculator is, you can change the settings and like make it give you different types of answers. Like when am I allowed to work with imaginary numbers versus when I'm not allowed? It's because how abstract are we thinking right now?
Okay.
Now, cube roots do not have a positive or negative answer, right? Square roots do. So if we're specifically talking about 46 being y equals the square root of x, technically, those will have positive and negative values as their answers. Except, can we do the square root of a negative 1?
No. No.
We can't do the square root of negative 1 under the, I forget if it's Euclidean or Cartesian, I think it's Euclidean, like Euclid, right? Understanding of mathematics. It wasn't until, and actually I still have today's lesson to teach you, but tomorrow I might show you this cool YouTube video that Estes sent me. When Estes is down like the nerd hole, like the rabbit hole, hopefully you guys understand this is a reference back to Alice in Wonderland and going down the rabbit hole. When he's down the nerd rabbit hole, he'll send me YouTube things. And one he sent me recently is like, where did imaginary numbers come from? Like, why the heck do we use imaginary numbers? And not imaginary like my bud Ted sitting back there by Anna. Imaginary is a misnomer. They exist. Imaginary, this is why I always put quotes on imaginary. Imaginary numbers do exist. Just, okay, stick with me. If this, indefinite's different. Well, that's a whole different thing. Okay, we're going down the rabbit hole when we shouldn't today. We'll have more time for this as we get further into the year. Max.
When I do square root of negative 1, it says error, non-real number.
That's because how your calculator settings are right now. But if you change your settings, it will give you the value of I.
What is I?
Square root of negative 1.
I don't know.
And negative 2 and negative 3 and
No.
Wait, what is the
Then square root of negative 2 is something I.
No.
Square root of negative 4 is 2I. Square root of negative 9 is 3I. And I bet you could start to figure out this pattern from there. Aiden.
Is it possible to have negative I?
Well, the opposite of I would be the opposite of the square root of negative 1. So is it possible? Sure. Does it do anything for us? I don't know. We don't know yet.
Is it complicated?
I don't know.
The answer is
So, hey Jake, stop. If you don't know what you were doing, that's a bigger issue. Nevin, we're not going down that rabbit hole right now. If you are very interested in imaginary numbers, I have this entire reference material all about imaginary numbers. So to give you the quick answer, of how do we graph imaginary numbers, we can't using our Cartesian plane, which is what our regular XY axes are. So to graph imaginary numbers, we have to lay our Cartesian plane flat on the table and then break the rules of physics, pull our plane up out of the table. Oh, thanks, Jake. I actually do appreciate that. So you literally have to pull into a new dimension where your X and your Y axes are on the table, and then we literally yank, like, break this, pull upward, and there is a different realm where our numbers can exist. So if you would like to explore more about imaginary numbers, I have this whole thing that goes into Euler and Bombelli. Bombelli was actually the first mathematician who figured out imaginary numbers. So this guy, no, Gauss, was one of the first people to speculate about imaginary numbers. And then you can kind of look at the table. Guys, this, like, we paid for this. I use school money, but this is because, like, imaginary numbers are so complicated. This goes into all the different civilizations and how they counted and the symbols they used and whether they understood certain things. Prehistoric civilizations didn't understand anything. Except for one, another one, another one. I have more ones than you have. Right? Like, if I have more sheep than you, I can say I have more sheep than you. Alright, this is way down the rabbit hole. You guys are... Stop it. Stop it.
Can I have that? I want to read it.
I have one copy of this, and it cannot leave my room.
I got dibs first. Alright, I got dibs first.
A first requirement would be green button on map before I loan that out to you. Alright, 10-1-3. Questions. And yeah, these all end up pretty close to each other. Notice that the gap between perfect roots gets further and further away from each other. The gap between perfect roots gets further and further away from each other. Other questions? Otherwise, we are going to formalize our volume of a sphere today.
Yay! Finally!
So let's review. All right, if that's done, turn it in. So go ahead and do that. What?
I think I gave you the binder.
Yeah, or some duct tape. Or some duct tape.
Can't fix stupid, but with duct tape you can fix it.
Okay.
All right, pull out graph paper. If you don't have any out, that's just silly.
Yeah. And a ruler. I'm not
Wait, I know how you can find the volume of a sphere.
Yeah, I know. It's insane.
You find a volume for a cylinder at the same thing, and then you divide it with it.
You need to duke it out. You need some, what are the bouncy blocks? No, the big ones.
Oh my
the
god,
super
yes!
inflatable ones.
Oh my god!
Or get the giant Q-tips. The gladiator.
No. When you have a big inflatable, like,
The sumo wrestling thing?
no, like the big inflatable spheres that you get inside of it, you just run it.
Oh, yeah. I want to play soccer.
I have done that, it's awesome. Have you ever played go-kart soccer? It's literally
I have
not
not.
big in real life, except no fun. It's the best thing ever.
So, we have...
But is there a binder that
Not at this point. Like, talk to me at some point when I'm not in the middle of teaching a class, maybe. I doubt it just dramatically exploded right in this moment. Like, you probably had some time to deal with that wasn't in the middle of my teaching time. So come when it's not in the middle of my teaching time, and I probably have a binder to hook you up with. Alright! Unless you know how to teach this lesson and would like to come up and do it, I have some things to teach you.
I try?
Do you know the formula?
No.
Then I bet you don't know how to teach it if you don't even know where we're going.
Oh, well, I
If you don't know where Disney World is, how are you going to get us there?
I'm gonna ask them.
So, the volume...
I'm gonna look it up.
The volume... That makes sense why my foot feels slippery.
Because your foot is slippery?
No, because I pushed it on it.
Can I have it posted?
The volume of a cylinder or the volume of on graph paper.
Oh.
We are not directly on a lesson paper right now. We're still trying to finish up last week's. We didn't formalize it.
Trying to see if I tried for this still, or did I just delete it?
Sorry, some of you seem like you need a moment, so I'll wait. Any prism, which is the same at top and bottom, we said has a volume formula of big B times H, where H is actually the distance between our bases, and big B is the base area. So big B is all this space in whatever your base shape is. Now for us, in a cylinder, we find the area of a circle by doing pi times radius squared. Max, I'm going super slow because I'm waiting for you to start writing things down. You might need to switch Max seats at some point so he's got an easier view up to here. And the height in this situation that we're trying to make easier than it could be, not easy, but easier than it could be, is what was our height? Not like, don't give me exact numbers. I want height compared to the sphere that we're going to work with. We said the height was the diameter, right? These are equally tall. So our height is actually 2 times the radius. Now, we're going to mess with this a tiny bit using our commutative property to move things around and clean this up. Kind of like term style, but we're not doing addition subtraction, so we're not actually worried. This is one term, by the way, because it took me a long time to understand that. This is a single term because it's all multiplication. Terms, multiple terms, you got to have addition or subtraction between them. So if I move this around, I'm going to put 2 times the radius squared times pi.
That's 2 pi, that's 2 pi radius cubed.
Now, radius squared is actually, if you want to write this all down, you totally can. Radius squared is actually radius times radius.
So 2 radius.
You can also just write radius cubed.
Swearing up a storm, people are. You can also just write.
You say I say it, then you say it.
But you did say it.
We need to say it.
Oh my gosh.
Or you put it like a quarter in every time you swear.
So this is the volume of the cylinder. Max took a simple interest loan from me today. Which is better, 5% simple interest daily or 25% simple interest weekly?
Do I have to do that?
25% weekly, which is what Max chose. So if he pays me back in under a week, the interest never hits. That's how you work your credit card. If you pay it back.
I asked for $1 for the egg thing. It's $1. I didn't have $1.
But what's 25% of $1?
25 cents.
So if you don't pay me back, I'm making money.
Max, I would have given you $1 if it didn't only have 20. Well, I think we can work.
Sorry, high roller. Never mind.
So that final, so the thing at the very bottom is the volume of the cylinder.
So this, now hold up. This is not always, hey, be careful. This is not always the volume of the cylinder. This is the volume of our specific cylinder that the sphere perfectly fits inside. Right? The sphere perfectly fits inside. Now, what we didn't really do last week, that we're going to try to do this week, is overfill things.
Yay.
So, I decided we didn't really have enough water last week.
Can I go get water?
Don't worry how much water we have. Oh. this guy back out. Oh,
Oh, Jesus.
not crash.
Crash, finally.
He's been looking at me all this
Wait,
time.
son of a bandicoot. All right, we'll fix him
No,
later.
son of a female dog.
Oh.
Marley? What? Don't talk bad about Marley.
Oh.
All right. So make sure we have enough water.
That's your drinking water, though.
Yeah, but I'll take it home again today.
Oh my god.
Oh,
Mr.
by
Hudson's
the way,
like,
I
I hope you don't have to go to the bathroom.
I had a question. At the end of the year, can our class sign one of the Jenga pieces?
Absolutely, each of you can.
Woo!
It used to be a thing, then it kind of stopped being a thing, and then COVID was a thing, and then.
You said the C
All right.
word.
All right. All right. So, which is bigger, the cylinder or the sphere? The cylinder. So let's see how many spheres it would take to equal. Let's get a nice relationship. Dude, you're distracting me. Please don't. Like, I'm not worried about you, but I can't focus.
Well, I know it's a fraction.
So,
And a nice thing.
I would say 1/4, 1/3 possibly.
It's 1/3 because all I'm saying 42. My dad's the answer to everything. So
The whole chapter 10.
all right. So one sphere, right? You guys said is less than this, but we don't know quite exactly what less. So, or like what portion?
It has one.
Pass and a third. I think the half line is kind of where it's been rubbed by the sphere. You can kind of see the half because it rubs from the sphere.
No, that is 2/3.
Now, do you think I can fit another sphere in here?
No.
No. So I think what we're gonna have to do is fill this the rest of the way up and then start over again. So, well, because if I'm gonna I don't want to dump this out yet, right? I want to see like how many. Here, stick with me. So right now we've got one sphere equals less than the cylinder,
Can I do it?
right? Sorry, I'm gonna.
Build half of the cylinder. Or the sphere. Build half the
I
sphere.
think it's gonna be half.
Oh, because then whatever
So
spills
then-
out is going to be.
All right, so hold up. So I will just finish
Hey.
filling.
Yay.
Now I will only finish filling the cylinder. I feel like you're gonna poke the ball here or something.
Let's go.
So you
Oh
guys
God,
can see.
Pikachu! I think you shook the ball too much.
What, dude?
All right, so without going crazy. So if half, and I've leaked some, right? If half of the sphere, you have to believe me that this is half because it doesn't look quite like it because I've leaked some. If half the sphere filled up the rest of the cylinder, then that wasn't half the cylinder. So 1.5 spheres equaled the cylinder. Wait, what's the 1.5? How could I say 1, Maddie?
1.5. So the sphere is 2/3 of the cylinder.
So wait, if the cylinder is 3/2 the sphere, right? We said the cylinder is 1.5, so 3/2. So if the cylinder is 3/2 the sphere, turn that statement around. The sphere is 2/3 the cylinder.
Oh my god.
So if the sphere, I'm excited. If the sphere is 2/3 of the cylinder, what's 2/3 of 2?
1/3. I got it right.
This is your formula for the volume of a sphere.
Oh, I looked up CPM and this is it.
With just this.
Any sphere, because radius, right? So the sphere size can change. Any sphere's volume. any sphere's volume is 4/3 pi r cubed, which the way that I remember this, I don't know why it works in my brain, is the 3 on bottom and this 3 right here. Now, we're not going to derive this on our own because we've got some problems to solve today to make sure that we understand what we're doing. We're not going to derive the sphere's surface area, but I will give it to you, and then some of you will probably, through your work, be able to say, like, oh, well, I see how this relates. Oh, it's because I'm still on highlighter. That's why it's writing all weird. The sphere's surface area is actually 4 pi r squared. So see how close the formulas are? They both have the 4 out front. But the volume then divides by 3 and changes the power to 3. So in my nerd brain, when I was learning this, I went, 4 and 2. They're both even numbers. They get along nice. They're really close to each other, 4 and 2. And then to take it to volume, we involve a couple 3's instead of this squared. We put a 3 below our 4 as the divisor. We're here, it would just be 1, right, if I wanted to divide by something. And then I change my power because now we're talking about volume. Our power changes to a 3. Brenda.
Is it
She had her hand up first.
a coincidence that the 4 and the 2 equal to 6 and the 3 and the 3 is equal to 6?
No, because remember, 2's a power. So don't, that's probably a coincidence, yes. If there is a relationship there, I don't know exactly why. Max?
Why is it squared? It's a circle.
Because area, thank you for that question, area is always talking about how many squares am I able to make.
You made it boring.
So
Stop it.
if I want to talk about the area of a circle, I involve squares, but I also have to involve pi, which is where we get all the little pieces from, is that involvement of pi. Because we can see this is nice in the middle, but then all the pieces are horrible.
I have a sudden desire to
Jake?
Wait, so is that like for every circle? Like,
For any sphere. Any sphere. So turn this into a sphere, and it'll work.
So the surface area too?
Surface area of what?
Like, is that the formula for every sphere?
Yes. Volume of any sphere, surface area of any sphere. Any. Now, the only thing that needed to be specific here is that the related cylinder had to have a height that was equal to the diameter. So what we did was we said, okay, if height equals 2 times radius, this cylinder would perfectly fit the circle inside of it as well. So that's why we did what we did, is so that that would fit perfectly inside of it.
It looks like a sphere.
It does.
You know, I need to be able to like spin it like a coin, right? Like when you spin a coin and like now it kind of looks like a sphere. Then
You made it boring.
I know, I'm sorry. We can only play with water so much. If you want to go to Splash Pad, that season's coming.
It was a joke.
What?
It's boring.
Boring,
I
boring,
said,
a hole,
why is it squared? It's a sphere.
right? But surface area is
He's just trying to get
Again!
the ball rolling.
Oh my god.
area is always talking about little bitty squares. The whole world is lit. If you come up here and look at the screen close enough,
Oh my
don't,
God, I
because it's
can't-
bad for your eyes. But there's
I can't handle you right now.
Can you handle T? What about V? S? Q.
Hey,
She was a bit too far.
Okay.
I think I can handle I-E-O-U. But mainly,
You do owe me. So I owe you. That's a good thing for you to remember.
but why?
Because you borrowed money.
he's XYZ.
All right.
That's why.
I can't remember what we did or didn't.
Why is X just pink?
Why
I don't even know where my 10-1-4 went to. So,
Oh my god!
the only thing that was really classwork was the pool. So go back to your 10-1-4 paper and let's actually solve the pool now that you know how, and we know our formula is 4/3 pi r cubed.
Mr. Hudson,
Yes.
I just realized why I wouldn't make and I forgot it.
Okay. We're sorry. We got to focus for a bit. All right, so you should have some work on this paper already. But if we... Hey friends, it's time to focus up. We've had a lot of fun, we've played with some water, we've splashed things, we've upset Anna, but now it's time to actually do math. So, our volume here, in this middle section, is how much of a cylinder? It's half of it, right? This is half of a cylinder. Forget about the ends. Forget about the parts that are partial spheres. Just this middle section, just this region. Wavy, 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 wavy. That is a cylinder, part of a cylinder, that is 20 feet across, 20 feet tall. So this tells us the radius of that cylinder is actually how much? 10. So our cylinder formula
Is base times the big B.
rude. You can say be quiet and be a lot nicer than saying shut up. So volume of, we'll do the cylinder first, would be big B times H. But then, do we have the entire cylinder here? Nah, we'll do something at the end to fix that though. We'll wait till the end so we don't get confused. We treat this like an entire cylinder. I'm going to say that again. We treat this like an entire cylinder. We'll fix it at the end. So if this is our cylinder, big B, radius of 10 feet, right, if we care to talk about units. So big B is pi times 10 squared. The height, the distance between your bases, is 20. So actually, this cylinder here has a height that's equal to its diameter, or a height that is equal to 2 times r. This is going to solve like the example one we just did, like using my physical sphere and cylinder that I had out. So this is actually, what's 10 squared?
100.
So this is 100 pi times 20, so this is really 2,000 pi. See why we might work in pi and not multiply by 3.14? Because it's way nicer. How much of that cylinder do I actually have? Half of it. So we now can divide by 2 and say our modified volume becomes 1,000 pi.
Well, wouldn't it be 1,000 half pi?
Well, it was 2,000 pi, but realize, so, good question. This, you guys, you only divide by 2 once. So you can't divide each piece by 2, otherwise you'd actually be dividing by 4. So this is just like writing 2,000 pi over 2, and you don't split up the division unless this was addition. If that was addition, we'd have to split it up. But that's this is one term, right? One term. What's the what? It's a pool. We're solving the pool.
It's a backbone.
Let's.
It's a big backbone.
Hey, so there's like 8 people talking. Does anyone else have a question? Max.
I actually do have a question.
Max.
Then there's very rare.
Brendan. Do I need your help teaching? Thank you.
Why don't we just solve the pi? I mean,
What do you mean? Oh, we can.
yeah, just go into a calculator.
We can. And really, I could... I don't want to use the J word, but I could multiply by 3.14 and literally just change all this to 3141.
That's what I was confused about. Like, why don't you just do that?
So what I haven't been able to get to, because everyone keeps trying to talk at the same time, is I don't do that till the end. Because if I had done that here, that would then make division by 2 more difficult.
Yeah.
I want to keep
But
my
then-
pi as long as I can.
That's why I wasn't confused about that, but now that we're at the end result, I think it's much less.
Now wait, this is not the end though. I'm going to have another value that I probably want to add with this. So you could multiply.
I just assumed that it's volume equals,
Yeah.
so I assumed that was the end.
You
That
could
the
multi-
end- that's like giving somebody the answer and then having them have to solve it. It's
Well, we're math teachers. So then, here's why I'm not going to multiply by pi yet. I got another value to find that's also going to involve pi. I've got my partial spheres on the end. We'll make these look like there's some algae floating in here.
You could find the area of the sphere and then divide by 2.
You mean volume
Yeah,
of a
well,
sphere.
oh, that'd be
So, if I put my two pieces of the ends of the pool together, what I end up with is a half sphere.
Can Max do it?
So, if we treat it like a full-size sphere,
Would Anna Sarkozy please report to the meeting?
nope,
Anna Sarkozy.
absolutely not.
Oh, this
Yes, thank you. People keep talking when I'm trying to do things, and it is distracting the crap out of me, and I'm not doing a very good job today.
Sir, no, I
No, you're good. You're allowed to leave since you corrected me on that. You're allowed to go. So our volume formula for a sphere, we'll only learn it if we practice it and write it down how it starts. 4/3 pi r cubed. Again, don't make 4/3 into 1.3, like keep it as 4/3. What's our radius here? Same thing it was, 10. Ten cubed is not just 100, it's 1,000. So, guys, what I'm going to end up with is 4/3. I'm going to change the order of this for a moment. I'm going to put my pi at the end. You know, because it's dessert. You put it at the end.
Oh my god.
So 4/3, crap. Now this becomes 4,000 divided by 3 times pi. But if we know we actually just want half of that, instead of 4,000 over pi, or sorry, 4,000 over 3, 4,000 over 6, or 2,000 over 3. Right? So you can either do 4,000 over 6 or 2,000 over 3. Now, let's go ahead and grab the calculator. What is 4,000 divided by 6? Or 2,000 divided by 3? Uh-oh. That's not a good number.
Times 5.
So, times pi, 3.14. Now, you could have used your pi button. So, actually, let me go back. So, guys, once we have an answer, remember, times... Hey, those of you that are just making side comments, grow up. Pi is right up here above your caret. You have to hit the second and then that button. Or, on the yellow calculators, pi is its own button. You got a pi button here. So you don't even have to hit any second function. You have a pi
It
button.
doesn't actually show you.
That will be more exact.
It actually doesn't show you. It just does this times pi.
I don't know what you mean by it doesn't show you, but okay.
It doesn't like show you the answer in numerical form. That would be 666.
Then you are in the wrong setting of your calculator. You need to hit mode and change from math print to classic. So it doesn't, you just have your settings wrong. So this is 2094.4 if we round feet cubed. My 1000 pi. This will not be a surprise. Oh, hey, look, it looks just like pi, just with the decimal moved. 3141.6.
So we need multiply.
Well, if I have this and that, if I have this and those,
It's add.
add. We want to add these together. Maddie, you got the final answer?
No, but I have a question.
Okay, what's up?
My old math teacher told me this. I don't know if it's still true, but should we use for pi? She told us to always use 3.14 instead of the pi.
Unless the problem specifically tells you which one to use, doesn't matter. I will accept both. On any state tests or anything, they will normally say use 3.14 for pi. Just because some calculators and or some people are not confident with like the pi button on their calculator, or if you're using like a calculator on a test, the pi button might be hard to get to. Like you might not know where it is. So yeah, a lot of times the test will say use 3.14. So if I add these up, 2094.4,
5, 2, 3, 6.
You supposed to just select them.
5,235. Yeah, we could have left them in pi form. 5,236. Feet cubed or cubic feet. All right, we will pick up some more application tomorrow because we actually know all the formulas that we need to now.
Oh boy.
Lucky us.
Have a wonderful day.
You too.